Welcome, everyone, and thank you for the nice introduction. The topic that I will talk about today is AI and energy storage and making batteries predictable. And ACCURE, as mentioned before, is a battery intelligence company. That means we use data provided by energy systems to make predictions about various things. But I will get into this in a moment. So let's start off. Why batteries? I mean, we talked about climate change already before, and climate change always means energy transition. And energy transition means more renewable energies. And whenever we have more renewable energy sources, we also have more intermittent sources. And whenever we have more intermittent sources, we need some sort of storage to buffer for that. And usually one state-of-the-art technology is battery storage systems in here, and there in particular lithium-ion battery storage. And so these will play a major role in here. And as already mentioned before, they find various applications. So this can be residential, this can be in mobility, this can be in industry, similar to what Johannes actually introduced in the building sector. And all these battery systems continuously generate data that can be collected and harvested and then turned into useful insights. And what can these insights be? These insights this continuous monitoring could be used, for example, to generate safety alerts or to estimate the end of life of a battery system, or also to automatically check the warranty conditions of a system. And what are the challenges that are coming with batteries? There are various challenges about this, but I would like to break it down into two. One on the is you can see right above my head here that the curve is going steeply up, so we are consuming a lot of resources here, especially in the lithium industry. Material shortage is already a problem, so saving resources is a very high need here. And for that, for example, we can extend the lifetime of existing battery systems by managing them properly and also enabling second life use. So we don't use a battery once and then just dispose of it afterwards, but we find an applicable second use scenario for it. The second one is that quite often the warranty times right now are more or less estimated by companies. So even if they sell it like now, whatever conditions they give here for like 5-10 years, the battery might break after 3 years already. And then suddenly we create a massive lack at the market where we need even more resources than we already know we need with an extending growth here. So this is challenges on the battery side of things. And what are the challenges on the data side? On the data side, we have the problem that whenever I talk about battery storage systems right now, I say systems because they consist out of many, many cells. So we imagine those little AA guys and a little bit bigger, that those are the industry standards. And you put these in bigger numbers together, they are called modules and packs. And in the end, they make up battery systems. And this brings the problem of scale because there's lots and lots and lots of battery cells involved here. And the manufacturing of those battery cells comes with proper challenges as well, because the manufacturing slightly deviates, even though the manufacturing skills have improved a lot. But even batteries from the same lot number still vary in their life expectation. Therefore, we have the intrinsic variability of the data coming from those batteries. Additionally, the internal states of the batteries are usually unknown because they are highly complex electrochemical systems. We cannot directly assess the quantities that we would like to know. But so now that we know what we don't know, what do we know? The only thing that is easily accessible of a battery storage system are usually electrical quantities like the voltage, like the current, and like the temperature. These three are continuously measured by the battery management system, or BMS. And this can easily be sourced from the outside as well and can be analyzed by, for example, battery experts. And what are the potential uses here? Now we know, okay, we have a tremendous amount of data. And there are actually many, many things that we can do with this. So first we record the data, as said before. And then we can do the so-called nowcasting, which means we estimate the current state of a battery depending on the quantities that we can access from the outside. So we only measure the voltage and the current and the temperature, but we can still also estimate, okay, how old or how much did it age in the meanwhile. Now, after knowing the internal age of a battery, we can also start to analyze what are the causes for the aging, how is it going to develop over time, and how can we predict how this is going to develop into the future. This also leads to further application like safer use of battery systems, as well as reduced safety hazards, the enabling of second life applications, and optimized operational strategies. And this is a very rough cut up now, but this is all I can deliver in 5 minutes. But I'm very happy for questions right now. And thank you very much.